Hello everyone, I'm Prarthana. Today I'm going to explain on the topic CPU scheduling. Let's get into the topic. CPU scheduling is one of the most important topic in operating system. CPU scheduling is the process of selecting which process will use the CPU next. Since multiple programs run at the same time, the operating system must manage them efficiently. Good CPU scheduling improves system performance and speed. Why CPU scheduling is important? CPU scheduling is important because fair process execution. Every process gets a turn to run. Next, reduces waiting time. No process is delayed too long because of CPU scheduling. CPU scheduling improves system performance. That means the system completes more tasks in less times. If there is no proper scheduling, some processes will be delayed and the system will be poor performed. Next, types of CPU scheduling. There are two types of CPU scheduling, preemptive scheduling and non-preemptive scheduling. First, what is preemptive scheduling? The CPU can stop a process if a more important process arrives. Next, what is non-preemptive scheduling? Non-preemptive scheduling, once a process starts, it runs until it finishes or goes into the waiting state. Preemptive scheduling is better for multitasking, but it has more overhead. Non-preemptive scheduling is simpler but may cause some delays. Next, let's see what are the criteria of CPU scheduling. We use some factors to decide if a scheduling method is good or not. Firstly, CPU utilization. CPU utilization helps to keep the CPU busy as much as possible. Next, throughput. Number of processes completed in a given time is called throughput. By knowing the number of processes completed in the given time, we can easily manage multiple tasks at a time. Turnaround time. Time taken for the process from start to finish. By knowing the turnaround time, we can know how much time the process uh, takes from start to finish the process. Next, waiting time. How long a process waits in a queue is called as waiting time. Next, response time. Time taken for a process to start running after it is requested to be run is called as response time. A good scheduling algorithms try to reduce waiting time and turnaround time while CPU increasing usage. Next, now let's see what are the CPU scheduling algorithms. There are 5 different algorithms in CPU scheduling. They are first come first served. Next, shortest job first or shortest job next. Next, round robin and priority scheduling, and lastly multi-level queuing. Each algorithms work differently. Some are simple and while others are useful for better multitasking. Let's see explanation of each and every scheduling algorithms. First, let's see first come first served. This is the simplest scheduling algorithm. In this process, the job which comes first gets executed first. The positive point of the first come first serve is it is easy to understand and it is easy to implement. But the negative point of the first come first to serve is it can cause convoy effect where a long process makes shorter process wait for too long. For example, let us imagine people are standing in a queue at a bank. The person who comes first is served first. Even if their works take too much time, maybe the people standing behind them have the less time tasks to complete. This may lead to convoy effect. Next, let's see shortest job next or shortest job first. In this method, the process with the smallest execution time is selected first. The positive is it reduces average waiting time. The negative point is long processes may stall. That is, it may wait forever if small processes keep coming. This method is best when we know the execution time of all process beforehand. Next, let's see round robin. This method is commonly used in time sharing methods. Each process gets a fixed time slot to run. After that, the CPU moves to the next process. In this, the positive point is every process gets a chance to run, making it fair. If the time slot is too small, too much context switching happens. Reducing it may reduces efficiency. For example, this is like a turn-based game where each player gets a few seconds to play and then the next player gets a turn. Okay, next, priority scheduling. In this method, each process has a priority number. The process with the higher priority runs first. Important tasks can be completed first by using priority scheduling. The negative point of priority scheduling is lowest priority process may never get executed, leading to starvation. That means then the process may never get executed. To solve starvation, we use aging, where a process priority increases over time. Next, multi-level queue scheduling. Here, processes are divided into different queues. The queues are based on the priority or process type. Each queue has its own scheduling algorithms. The positive point of multi-level queue scheduling is it separates processes efficiently. But the negative, that is the disadvantage, is it is complex to implement. For example, a system may have one queue for interactive task and another one for background task. Next, let's move to multi-level feedback queue. This is an advanced scheduling method. Processes can move between different queues based on their behaviors. It prevents starvation by adjusting process priority. The bad part of multi-level feedback queue is it is also hard to implement like the multi-level queue scheduling. Next, what are the deadlocks available in CPU scheduling? Deadlocks happen when two or more processes wait for resources indefinitely. Common in priority-based scheduling where higher priority process block others. The solution to prevent deadlock or use deadlock prevention techniques like timeouts and resource allocation policies. Next, let's hear. Okay, now let's see what is context switching. Context switching is the process of saving and restoring the CPU state. When the switching between the processes takes place, it is essential for multitasking, allowing multiple processes to share CPU time. However, too many context switches can slow down the system due to overhead. For example, in round robin scheduling, if the time quantum is too small, context switching happens too often. Redundancy, it also reduces the efficiency. To minimize overhead, operating system optimize context switching by reducing unnecessary switches and using better scheduling strategies. Next, shortest remaining time first. Shortest remaining time first is a preemptive version of shortest job next. The process with the shortest remaining execution time is always executed first. If a, if a new process arrives with a shorter burst time than the current running process, the CPU switches to do immediately the shortest burst time process. The advantages of CPU shortest remaining time first is it reduces waiting time and improves responsiveness. Next, impact of CPU scheduling on performance. CPU scheduling has a direct impact on system performance because good scheduling algorithms improve system responsiveness and resource utilization by efficiently managing CPU time. Poor scheduling can lead to bottlenecks, delay, and low CPU usage. For example, FCFS is simple but can cause long waiting times. SJF minimizes waiting time but may lead to starvation. Round robin ensures fairness but increase context switching. Choosing the right scheduling algorithm depends on system workload and requirements. Next, CPU scheduling in multiprocessor systems. In multiprocessor systems, scheduling becomes more complex because multiple CPUs must share tasks efficiently. Some key challenges may include load balancing and processor affinity. Scheduling algorithms in multiprocessor system aim to minimize CPU utilization and system throughput while ensuring smooth execution of multiple tasks. Future trends in CPU scheduling. CPU scheduling is evolving with new technologies. Future trends may include AI-based scheduling, power efficient scheduling, and hybrid scheduling techniques. As computing demands grow, operating system will continue to improve scheduling strategies for better performance. Next conclusion. To summarize, CPU scheduling is crucial for efficient process execution in operating system. Different scheduling algorithms have trade-off between fairness, efficiency, and complexity. Choosing the right algorithm depends on system's requirement and workload types. Future advancement will focus on AI power efficiency and hybrid scheduling. This is the end of my presentation. Thank you.